It's good to have you back here. How are you? Now, we are going to consider these two given functions, f of x being x plus 7 and g of x is 3 minus 2x. And we are going to show the result when we use the composite operation or composite functions of both. But we are going to have the composite function of the function in itself. Let's have this notation. What if I have f of x? This means that we are going to take the composite function of f of x in itself. This is actually similar to stating f of x. Instead of f of x, your variable x in your function of f of x will become the same f of x here. This is how we do it. Instead of x plus 7, again it's x plus 7 here, this variable x will become the function f of x itself. So we are going to change it to the function of f of x itself, which is the same thing, x plus 7. Take note, I just used parentheses here because there might be some operations later that will have here numerical coefficients. So for us to practice it, we're doing it like this, but nevertheless, it won't affect the result because we don't have the coefficient here. So take note, this is supposedly x plus 7 earlier, but the x itself became the function of x. We have x plus 7. So with that, we can now remove the grouping symbol. It will become x plus 7 plus 7. This is the original 7 here. In short, the result of f of x is equal to x plus 7 plus 7, 14. This is the composite function on f of x in itself. Let's have the second, g of x. So same thing here. We have g of x, but instead of the variable x, we'll be using the entire value of the function g of x itself. So supposedly, our given function is actually given as 3 minus 2x. This is our original g of x. But this here will become the entire g of x in itself. So instead of that, we'll have it as our function of g of x, which is the same 3 minus 2x. Notice again that we are using parentheses because this is very critical, because if you were going to forget writing like this, you're just stating that you're multiplying negative 2 to 3 and leaving out the minus 2x here. But because it's a numerical coefficient of the original x, which we transform to g of x, we need to place parentheses so that we are also going to distribute that to the second term. This would mean, by application or removing of grouping symbol or distribution of negative 2, we'll have 3. Negative 2 times 3 is negative 6. And negative 2 times negative 2x, you'll have positive 4x. Again, negative 2 times 3 is negative 6. Negative 2 times negative 2x is positive 4x. With this, the final result for g of x is 3 minus 6. You have negative 3 plus 4x. Or, if you would like to rearrange it, you may also do it like this. 4x, positive 4x. But don't forget that 3 here is negative or minus 3. These are now the results for the composite functions of the given functions in itself. That's all for today. You're dismissed. And please do not forget to subscribe now.